Hello, in this video I'm going to solve an example in which we find probability of intersection of two events, knowing the probability of each event and another piece of information. One thing to know is that just knowing probability of E and probability of F, we cannot determine what is probability of E intersection F. We need another piece of information. And in this example, we will see how we can get that intersection knowing another piece in different situations. Let's see. The question starts like this: let E and F be events defined on the same sample space with probability of E given is 1/2, probability of F is given 1/3, and the question says find the probability of intersection of E and F if part A says E and F are mutually exclusive, part B says E and F are independent events, part C says that, well, the conditional probability of F given E is given, and part D, in part D, the intersection of, probability of union is given, and we have to use that plus the other information to find the probability of intersection. So I'll go one by one. In part A, it says E and F are mutually exclusive. Mutually exclusive means that, well, they have no intersection. Well, if two events have empty intersection, then probability of intersection is same thing as probability of empty set. But based on the properties of probability measure, we know that the probability of empty set is always equal to 0. That's part A. Mutually exclusive means the intersection is empty, and we don't need even the information about the probability of E and F, but the result would be that the probability of intersection is 0. How about E and F are independent? What does E and F independent mean? Independent mean that well, knowing F happened or doesn't change the probability of E. So probability of E stays the same if we don't know if F happened already or not. So this is the definition of independent event. In this case, we say E and F are independent. But, well, this has a result, this has a consequence in which says that if E and F are independent, then probability of intersection is product of probabilities. So we have probability of E, we have probability of F, you multiply them, you get probability of intersection. So in part B, since E and F are independent, so the probability of intersection is going to be product of probabilities. In this case, is 1/2 times 1/3. This is 1/6. So this was for independent, and that was for mutually exclusive. Part C says, well, we not only have probability of E and probability of F, also we have probability of intersection. Conditional probability of F given E. Well, to be able to find probability of intersection, we have to know a formula for conditional probability. For conditional probability, we have probability of an event knowing another one is you have probability of intersection and then divided by probability of the given part. So this is the conditional probability formula, and here I can use it to find intersection. Note that there is a probability of intersection in the numerator of this probability. Basically what I have is probability of f given E, which I know is 1 over 5. It should be equal to probability of E intersect F divided by probability of E. I know that probability of E is 1 over 2, so I have 1 over 2 here. Probability of E intersect F. I know that probability of intersection over half is equal to 1 over 5. Then I can use it, and I find probability of E intersect F is nothing but 1 over 5 times 1 over 2, which is 1 over 10. And that's part C, which says if you know conditional probability and probability of the given part, you can find probability of intersection. And the last one comes from very famous and nice formula, which is called inclusive-exclusive principle. It says that probability of intersection is nothing but probability of E plus probability of F minus probability of union. You guys may see this, might have seen this formula in other way around, such that you have probability of union on the left hand side and probability of intersection on the right hand side. That's the same formula. It says probability of union is probability of E, probability of plus probability of F, but you have to subtract intersection part. And now if you have 3 of these, you can find the other one. In this case, I have probability of E, probability of F, I have probability of the union, then I can find probability of intersection, which in this case would be E intersect F is probability of E 1 over 2 plus probability of F 1 over 3 minus probability of union is given 2 over 3. This is 1 over 3 minus 2 over 3, so I have half minus 1 over 3, which gives me 6 in the denominator, 3 minus 2, and that's 1 over 6. Well, the summary is, again, if you have probability of E and probability of F, you cannot determine probability of intersection unless you have another piece of information. That other piece of information would be if E and F are mutually exclusive, or E and F are independent, or the conditional, one of the conditional probabilities are given, or the probability of union is given. This video was basically a review of formulas for the first half of the chapter 2.